Welcome to this edition of When the Biomass Hits the Wind Turbine, a discussion of sustainable living and what that means to you and me. I'm Jay Warmke.
And I'm Annie Warmke.
Hello, Annie. And today we're going to talk about straw bale construction, or we'll huff and we'll puff. And my buildings will probably fall over.
That's what people were saying when you first started building.
Huff and puff construction.
Right. Yeah.
So tell me a little bit. I mean, let's talk a little bit about what is straw bale construction, because a lot of folks who are kind of into sustainability, they hear this, they kind of, like it without knowing what it is. So tell me a little bit about straw bale construction.
Well, first of all, straw bale construction has been around probably since the beginning of time. And lots of places don't have trees or other building materials. And if you think about the Midwest of this country, when people were pioneers trying to settle, there were no trees. So they used what they had, which is a great basis for anything. And they used grasses, and they made straw bale or mud buildings to live in. And some of those buildings were really quite nice, and they still exist today. And straw bale construction really is basically one of two things: either building a frame and filling it in with bales of straw by, we take saplings and nail them to the wooden frames of the building, and then we sew with baling twine the straw bales to the...
Okay, well, we'll get into more specific because it's sounding like first become a millionaire, then don't pay your taxes.
All right. Well, then secondly, you can use the straw bales as load bearing so
as
that they
support.
Yes, so they support the building. But
they'll often refer to that as Nebraska style, because in the Midwest, as you said, when there were no trees, nothing for physical support of the roof, you had to use the walls. You had to use the straw.
There was nothing. But straw bale is really just it's just filling in space. Mm-hmm. And you're trying to create a wall that gives you a good R rating for insulation, and it's giving you a nice soundproofing. And straw bales are pretty available, although not as cheap as they used to be. I think they're going for somewhere between $6 and $7 a piece.
Holy Toledo.
Yeah, which is
cost of construction going through the roof.
Well, it's the tariffs. The problem with the tariff.
We're going to stop all these imported bales of straw.
Well, let me say, you're laughing, but I'm not kidding, because there have been farmers in places like Arizona where nobody should be growing grasses. And so they're using a huge amount of water to, what's the word I want?
Grow?
No. When you spray water on something.
To irrigate
these and spray them in the desert.
I'm here to help.
Thank you, Jay. Mm-hmm. You're so sweet to me. And they're using the desert to grow.
Right, I did hear they were shipping those off to the Middle East, to Saudi Arabia.
Something like 10,000 acres of ground is growing hay to be shipped and straw to be shipped. Sorry, but they're using bales of dried grass, which is what we're talking about, or dried stubble from wheat to be shipped to the Middle East, where they have all these horses and stuff.
Well, what we're saying there basically is any material can be unsustainable if it's harvested in an unsustainable manner. But the heart of sustainability is using what's locally available, readily available, oftentimes waste material that would otherwise not be utilized to that high a purpose. And straw bale in many parts of this country is a good option. It's an option that's been around for a while.
One example might be like in the Northern California, where they grow lots of rice, which is bizarre if you think about it too. But then they burn the stubble instead of baling it.
Sure.
So the material is really plentiful if we just were to use it properly.
And typically straw, as opposed to hay, is the inert, without nutrients.
Yeah, non-nutrient.
Leftovers after you harvest a grain. It could be wheat, it could be barley, it could be rice, as you mentioned.
Mm-hmm. But in my experience, I don't see it that much. I mean, I do know that hay has more seeds in it, but the straw that we've used in our buildings have lots and lots of bits of wheat
Right,
in it.
and that can be problematic.
It is
In
problematic.
fact, after we've mud plastered them, on occasion, these straw bales look a little like chia pets. All of these seeds start sprouting out through the mud. And fortunately, the main structure of the fiber is not going to compost within the wall, which is one of the reasons why you would not use hay. You wouldn't want hay, which will degrade, will compost over time. And of course, as it composts, it can heat up. You want something that's inert.
Well, I would disagree just slightly because I think it's all the same thing. It's the amount of moisture that gets into the wall that's going to cause it to decompose, or goats eating the wall and causing it to collapse and crazy things like that. But moisture is the biggest, and rodents getting into the walls. Those are the biggest problems with straw bale.
Okay, well, let's walk through the steps then. For a typical, let's say you want to go out into the woods, build yourself a little straw bale cabin, sit back and wait for the next administration to take over. And you're going to sit out there on the front porch and look at the clouds. So you're going to build yourself a straw bale cabin. And the first thing, of course, you need is a good foundation.
No,
right?
The first thing you need is to make sure that the zoning is going to support what you're about to do.
We're out in the woods. We don't need no stinking zoning.
Okay, well, you may end up with no building either. So you need to know what the rules are if you're going to break them.
All right. Well, we're gonna assume a utopia without any government interference here, and we're going to build our foundation.
Yes.
Right. So the foundation. Some of the examples we like to use rammed earth tire foundations, because that comes from the heritage of the airship, and it actually works out quite nicely because they're about the same width as a straw bale, so they support the straw bale pretty nicely. Some other examples of foundations might be the rubble trench foundation.
Right, we did that over in the Westfield barn.
Right, where you dig a trench essentially below the frost line, and then you fill it with large stones so that there is space between it, but still it will support the wall. And that space between allows any expansion, contraction, and moisture to do its thing without heaving and shifting the building.
We also did that model on top of tires so we could widen. So I know you like to do a 2x6 across the top to make a plate, but we in the other construction we did, we had 2x4s, and then we had gravel between that, so there was a weeping place for the bale if it got moisture in it.
And you could use traditional foundations, sure.
Well, cement
and the
block
like, or
isn't very
concrete
good.
Block.
It'll draw moisture.
Yeah, and of course there's a lot of cost involved in that as well. The concrete costs quite a lot. But assume you've got your foundation, then the next thing you have to worry about is some sort of support structure. And as we mentioned earlier, there are two different really types of walls that you're going to be dealing. They're going to be load-bearing straw bale.
Or non-load-bearing straw bale. How about that?
Yeah, and the non-load-bearing, you're relying upon some framing of some sort. Could be traditional 2x4 type walls, which are not very effective because they're 16-inch centers, which isn't enough space for your straw bale. Or, again, what we like to use is a modified timber frame type of construction. And that works pretty nicely, and you can space the support members based on the size of your bales if you don't want to cut down the bales, as often as you might otherwise have to. And if you are going to use some sort of wooden structure to hold up the walls, you need some way to attach it to the foundation. So
you mean the 2x4s?
Well, whatever the wooden support structure is has to be attached. With the tire foundation, we typically like to do a sill plate and then use rebar and pound through the wooden sill plate into the tire. But then you can leave the rebar exposed and then just impale, like Vlad the Impaler, impale these straw bales on top of the of this rebar and fill in that space. As you say, with any kind of sustainable construction, you're basically filling space with stuff, which I like to say should be our national motto, filling space with stuff. Instead of "In God We Trust" on every dollar bill, it should be United States of America, filling space with stuff, right?
No.
You're giving me that look.
I'm just like,
So
how did we get there?
Where is that going?
Yeah.
So anyway, so you've got these walls. You fill up the interior of these cavities with straw. And in order to do that, typically the straw bales aren't going to fit nice and tidy in there. So what's the process you go through?
Well, meaning how do you make it fit?
Yeah. How do you get those bales in there?
Well, if you framed it properly, they ought to fit pretty tightly.
But you're always going to have to offset them a bit. So I guess what I was getting
that's
to
true.
is the retying.
I was going to. I was getting there.
I'm trying to lead you down the road.
I know.
There.
Well, you're in a hurry, I guess. So it's pretty simple to take some of the biscuits out and then retie the bale. You can make like a jig where you can smash the bale really tightly by somebody sitting on it and then retie it. You can. Some bales, I know when the first straw bale workshop that we did over in the Westfield, we actually had an electric chainsaw and we sawed bales to put them into shape and
just to fit around.
Yeah, to fit around
wooden structures and the like.
So that's pretty simple. And then once it's retied, we're going to ram it into place. And in our building style, we gather up little saplings, about the size of maybe your thumb or a little bit bigger, and those are nailed to the frame on the back side, and then we push the bales in and then put some more saplings in the front, and that gives us something to tie the bale to. And then we have needles that we've made, giant needles, that we can shove through.
And when you say a needle, a straw bale needle, it's basically a 1/4-inch metal dowel.
Right.
Where you can attach twine to it and
feed
feed it through the bale. So it's got to be at least the width of a bale, so at least 14
you mean the
inches.
length of it?
No, the width.
Right, but I mean the length of the needle has to be the width.
Yes.
So you just shove that through, and then you've threaded the needle, and then you tie the bale off to the sapling, and basically we call it sewing the bales to the wall. And once we've done that and the wall's pretty sturdy and nothing's moving very much, then we're going to say, all right, what do we do to start making that wall look like a beautiful, flat wall that somebody would like to have in their building?
Yeah, because at this point, you essentially have a wooden structure with straw bales in filling up the gap with twigs or saplings, and it's all corseted together so it's one unit, but not something that someone would want in their living room at this moment.
Well, if you were building your house and you wanted to have it paid for while you were doing it, it would probably be something to be really proud of. But then the next thing we're going to do is mix up some clay and some maybe some sand or maybe just some loose straw that's fallen down, and we're going to make plugs, and we're going to start filling in around those bales and where the wood is and the 2x4s, and start making everything be nice and even. And then when we're done with that, we're going to mix up another recipe of clay that we call earthen plaster, and we're going to start plastering over the straw bales.
So the first step, you're taking big globs of clay, or even we've used bottles and cans to fill in
anything
the
to fill
gaps.
in the space,
and you're just kind of get a semblance of a smooth wall. Fill in the big gaps
base
first.
Yeah.
Then you're coming over it with the scratch coat, essentially, which is a combination of straw, sand, and clay. Which in the mud plastering world, it's sort of like baking bread. It's all the same ingredients, but they're just in different mixes. You're listening to When the Biomass Hits the Wind Turbine with Jay and Annie Warmke, reminding you, once again, it's truly the end of the world as we know it.
And thank God.
Thank God, this unsustainable world. So everything comes to an end except building sustainably. So we're talking about straw bale construction and walking through some.
What comes to an end except for straw bale construction?
Everything.
Everything
comes to an end.
Oh, you're a picture of hope today.
That's right.
You've been watching the news too much.
No, I'm not. I'm just a realist here. So we're going to be building a structure, and typically the way we've done it is we built the foundation out of rammed earth tires, which is a nice, inexpensive way of doing a really high quality
labor
foundation.
intensive, kill you, but
That's true.
But cheap.
And then you,
Like you.
timber frame, labor intensive and cheap. Except for the labor intensive part, you're right on.
No, you like other people to be labor intensive, and you watch.
I'll supervise. I get paid more that way. So then we have the support structure. Then we're going to fill it with straw bales,
spaces,
and then we're going to corset it with saplings. Then we're going to fill in all of the little gaps and areas between bales and imperfections with mud. And now we're going to put on a scratch coat. So we're going to cover the whole surface.
Right, but you forgot
mud.
to mention, and this is my favorite part, is the use of the chainsaw. So one of the buildings that we built with students, we actually filled in the space with students. Down at the Peace Porch.
No, we use straw bales. The students,
no, with the students.
students help. All right, don't get
No, we didn't
don't get
put
out of
any
control
live
here.
bodies into the wall. Although
they were composted.
I just want to say some of the holes were big enough of a live body. A small person live body would fit. But anyway, so I was doing this with a couple of interns, and we were trying to finish the space so it would be livable. And when we went down to look at what we were dealing with, there were two women, and they looked at me and they said, "Annie, how are we going to finish this wall? It juts out, the bale juts out, and the door is impeded from how it juts out."
It was basically a herniated wall.
It was unbelievable that anybody had left it that way. So I said, "Look, the only thing I can think to do, which we're going to just be women of power, we're going to get the chainsaw, and I'm going to just saw the heck out of the wall." And they were like scared. "Oh, my God, the wall's going to fall in." And I said, no, because they'd already plastered some of the wall. So it was pretty solid in a lot of ways. So I got the chainsaw, and I just started going down the corner of the wall. And we made a nice, smooth, rounded curve in the wall. And today, you'd never know, it looked like, I don't know, Picasso had somehow had something to do with that wall.
With the nose sticking out sideways. So,
but
this
but
brings
that's
up.
the thing. That's the thing that's so great about these kinds of types of construction is they're what we call forgiving. So there was a lot of screw ups in that wall. We filled in the holes that we didn't want. We sawed the wall to get it in a position where it looks beautiful. And we covered it over with earth and plaster, a variety of recipes of earth and plaster, and you'd never know what happened.
Well, we do like to say that as long as someone's good at the finish work, you can cover over every mistake, and you will make mistakes every step of the way. And it's nice because it is a forgiving. It's a very plasticized. It's very giving and forgiving process.
Or you can make it rounded, curved.
As opposed to like traditional, well,
like
I say
boards.
traditional, but the way that we construct today with 2x4s have to be on specific centers with drywall and pre-manufactured units.
And all that plumb
if you're
stuff,
a quarter of an inch off, this plumb. If it goes up and
Forget it.
down,
I know, forget it.
What's a level? Who cares about
I know.
level?
Well, that is your the interns.
I always like to
teach
say
you.
that, anybody can make something perfect. It's the true artist that incorporates all the imperfections into the process.
I remember we had an intern once who you got really upset with, which normally didn't happen and doesn't happen. And she informed you that a structural engineer should look at what you were doing. And you said, "Look, I have 16 buildings and they haven't fallen down in 15 years. I don't need no stinking structural engineer." And she got mad and she refused to work with you.
Yeah, well, I figure if it doesn't fall down, it works. So that's why I'm not building bridges.
Oh, thank goodness.
So,
that would be scary.
but actually, and that does bring up a serious point, relatively serious, is because of my lack of engineering gravitas.
What
Typically,
is that? Wait. What does gravitas
that means
mean?
I don't know what I'm doing. So anyway, because I don't know what I'm doing, we tend to size the support pieces, the support wood, all these other things, make it so robust that it will forgive a lot of the ineptitude of construction.
I just want to ask one question. All right.
go
So for prior to 15 years ago, I would say you would say that you don't know what you're doing. Because I remember the first bookcase you made before we were married, and I was afraid of it. It looked like it was in some kind of earthquake all the time.
You said Picasso.
All right, I said Picasso for myself. But I would say that anybody who has constructed as many buildings as you have out of unconventional materials, that you innately have a sense of how it works and why it works, and also the ability to teach people how these things work. So I think you are either being goofy or modest, which is not either one of your
I'll
normal.
be goofily modest
All right,
about
goofily
this.
modest.
But anyway, yeah, and you're right. As you do more and more of these things, you do get a certain knowledge base in this, but it doesn't stop you from over-engineering. I think that's always it's better to make it more robust than less robust. And we've had a lot of situations where this has come in and helped. For instance, the Dogwood Chalet. That was a good example of a
that
building.
was in the beginning, before you did know what you were doing.
It was in the beginning, and it was also near the end because it took probably 15 years. But that poor building, pretty much everything that you could do wrong, we did wrong, and even nature conspired against us.
Wait, we had help. The people, our first students, leaned on the building.
Yeah, they kind of were holding. Well, that's a whole different. I don't even want to remember that. But I won't blame the students. But a big tree, actually fell on it and poked its branch right through the roof, knocked the building all, as they like to say, cattywampus. And so this thing is leaning over like a domino about to fall into the next building.
Holler.
And,
into the holler, because it's downhill from there.
But just to show you how forgiving this construction is, we were able to, with a bobcat, we pushed the building up straight, braced it, and quickly covered over all of our mistakes and pretended like nothing ever happened. And now it's a beautiful, as far as you know, a beautifully structurally sound building.
Has a deck on it,
yeah,
and
it's
cute
beautiful.
little windows, and everybody loves that
So
building.
you can make these things work even when the world and ineptitude are conspiring against you. Another thing you can do is incorporate art. This is one of those like whimsy things.
We've had so much fun creating like a dragon on the outside, a fire-breathing, loving dragon on the outside of one of the buildings. And the Dogwood, which we're just talking about, has a beautiful rosette glass window, which is actually bottles and the cap from coal mine lights with a huge dogwood blossom painted around it.
Well, and speaking of the bottles, how do you incorporate those see-through bottles into the walls?
Well, we have a tile cutter, which you can rent if you don't want to buy one, although they're inexpensive enough. And so depending on how wide, like is it a 2x4 or 2x6 or whatever the width of that wall is that we're trying to get the light to go through, that's how wide the bottle's going to be. And so what we do is we cut 2 bottles. We cut the ends off of 2 bottles.
And they have to match.
They don't necessarily have to match.
No, in my ADD world,
all right,
they have
in
to
your
match.
world, but in my world, they wouldn't have to match. And then you tape them together with some duct tape, and then you lay them into the wall, either in earth and mud and kind of thing, or a recipe, or concrete, and you can make a pattern, or you just put them in however. But they make a lovely decoration, and they also allow light to filter through, and it's quite a fun thing.
And they come in a variety of colors. You get blue bottles or green bottles, yellow bottles.
We were very excited
clear.
when the beer companies started making all those beer bottles that were blue, and the interns
Go
who didn't
Bud
even
Light. Woo.
Yeah, I know. We'd go to get the bottles, and they'd say, "We never thought we'd live to see the day." We'd say, "Could you drink more beer?" But my favorite, I have to say, my very favorite whimsy is Mr. Moon. And he's on the outside of the Peace Porch, and he's a face that I have drawn and have several different antique little replicas of, and he's made completely of trash. And when I was working with the interns, they just could hardly believe that we could make this amazing face just by building out and making a 3D effect, and then making nose and closed eyes and beautiful cheekbones, and And then we took broken glass, a really heavy mirror that we busted up, and there's twinkles all around. So on a day like this, it looks like that Mr. Moon has a big sparkly thing going on around him. And he is huge. I mean, I think that it's like a 4-foot diameter face, and just a fun thing. So we have a lot of fun.
It is just limited to your own imagination, your own art ability.
Yeah.
So it's nice. It's nice to incorporate art in with the construction.
Well, just to say that one of the things that I use a lot in the construction are sticks. So I've used sticks to create shelves, to create a window. What do you call that? When you have the
ledge?
Ledge. No, it's not a ledge, but that'll do.
And, all right, I'm going to start bringing a thesaurus along.
All right, I'll
to
look
these
it up.
things.
But or when we make these relief designs, we use lots of sticks to
build out. And you just stick them in when the plaster is wet, and then they set up and they provide a structure for the protruding bits of mud to adhere to.
Well, we call it relief. And so we can build
the
wall out.
It's a relief when it's finished. Right?
Well, maybe. But we can keep building the wall out with more and more sticks and get deeper and deeper.
Well, when we first started on the whole straw bale construction thing, bless you, that we got a lot of emails from folks primarily in the desert Southwest saying, okay, you cannot do straw bale construction in Ohio. It won't work there. And clearly it does. I mean, we have buildings that have been around for 15 years that are doing just fine. So that's one of the things to overcome is this sense that this is a dry climate only situation. And really what we'll say is in order for straw bale structure to succeed, it needs good boots and a good hat, meaning a good foundation, keep it up off the ground so the bottom of it is not getting wet. It's above the snow load, wherever that may come to, and then a good hat.
Or you keep the snow away from it. That's a better,
you shed it off.
Choice.
You shed it off away from the foundation because water will wick up through the earth and the mud if it has a chance. I mean, water's going to go where it's going to go. So then, I guess the other second thing that often people will raise is what about permits? What about costs? Is it an expensive process? Are permits available for this kind of thing? And I know there are international building codes for straw bale construction. If you're looking to do something very legitimate like a home, usually your locale will accept the international straw bale building guidelines, permits, and the costs are whatever they are.
Right, and also permitting. That's up to your local government. But there's also some national association for straw bale construction, and so you can look into that as well.
Mm-hmm. So as far as cost is, that's one of those how deep is a hole, how long is a string. It's going to cost as much.
How many friends do you have, and how much beer do you want to give them to help you?
That's right. So get out there and start building your own little straw bale. And as we'll say, your first project should not be your home. It should be
try a doghouse.
A doghouse for storage.
Or a birdhouse.
All right. Well, you've been listening to When the Biomass Hits the Wind Turbine with Jay and Annie Warmke. Thanks for spending just a little bit of time with us. And as your grandmother surely told you, the secret to a happy and sustainable life is
play nice with others, clean up your own mess, and for heaven's sake, Jay, eat your vegetables.
And her children will be